Okay, absolute value. They put absolute value in, if you remember, we just got done doing compound inequalities. Compound means what? Multiple. Absolute value is the same type of deal. If you remember, absolute value is just two straight lines on each side of a number. What's the absolute value of negative 3? 3. What's the absolute value of 2? 2, right. Absolute value doesn't mean change the sign. It means it's always positive. Okay? Put your iPads away. The types of problems these are used on is distance problems. Because distance is never negative. If you drive backwards, you're still traveling a positive distance. You're just going backwards, okay? So, this is the most basic absolute value equation that there is. Okay? What would x equal to make this true? 3. Anything else? Or negative 3. Because if I put a 3 in there, it equals 3. If I put a negative, it equals 3. So what you need to remember about these, absolute value equations have two solutions. Okay, you're not just going to get one like when you solve a regular equation. You're going to always get two solutions. They're not always going to be opposites of each other. Sometimes people solve and get one answer and then just put the opposite on there. Now, a shortcut is you could just write the number, if they are the same number, you can put plus or minus in front. Or you can write them separate like that. Doesn't matter. So, if we were to solve this one, I'm going to show you the shortcut way to solve them. And you did do this last year in 8th grade. Whenever it's absolute value, because you're going to do it this way too if it's an inequality, because we're doing inequalities too. You rewrite it, and then what you do is you put the same sign on the other side. So when we get to greater than or less than, you'd put the same sign over here. And then you put the opposite of whatever it's equal to on this side. Now it just turns into a compound, which means you just get the x by itself in the middle. So what do we do to get the x by itself? Minus 3, minus 3, minus 3 to all of them. So my two answers are 8 and negative 14. That's the quickest, easiest way to do it, is to write it like that. They won't show you that way in the book. They have you write it out both ways. And you can always check, if I put 8 in here, 8 plus 3 is 11, which would equal 11. If I put negative 14 in there, I get negative 11. But then that changes it to 11. So here's an example where they're not opposites. One is positive, one's negative. Carly, you got to put that away. Now, the rule for this is when you have an absolute value equation, before you put the other sign on the other side, you got to get this by itself. You want just an absolute value by itself. So here there's a plus 5 on the same side. So you just move that right away. You minus 5. Then you get 3x minus 7 equals 4. Like that. So then you put the same sign here. Put the opposite here. And then just get the x by itself in the middle. So it's a minus, so you add 7, add 7, add 7. And then divide by 3, divide by 3, divide by 3. This is 1. When it's an odd fractions like that, you can just leave it 11/3. Or you could put that as 3 2/3. Or if you do divide it out, 3.6 repeating. You can write it any which way you want. They're all correct. This is the easiest though, because you don't need to go any further. Okay, so the biggest thing you gotta remember, it's solved just like our other equations, it's just, you're gonna have two answers. So you gotta remember to put the opposite on the other side, on the absolute value. The inequalities are done the same way. It's less than or equal to 23, put the same sign over here, so they're gonna point the same way, and then put the opposite. And then you just get the x by itself. So I gotta add 7, add 7, add 7. Let's see, that would be negative 16. Then divide by 5, divide by 5, divide by 5. Again, you got an odd fraction, you could just leave it like that if you wanted to. If you divide it out, that'd be negative 3.2. Or again, you can just leave that. Okay. We don't have to graph these as much because we've already gone through the graphing part, but just to remind you, if we did graph it, negative 3.2 would go there, 6 would go there. They're both equal to, so you put filled in. X is less than, so it's to the left of 6. X is greater than, so it's to the right of that, so they connect. So this is the same thing. It's a greater than, but this isn't by itself. So if it's not by itself, you got to get rid of that. So 8 minus 2 is 6. Now it's by itself, so put the same sign here, put the opposite there, and then get the x by itself. All you got to do is add 11. And you're done. Okay? There are some that have stuff multiplied times. Let's see if they got one of those for us. No, they don't. Let me make one up. I'll do a multi-step one. Say we got this. Oh, I'm going to change this so we remember that. Okay, this is as tough as they get, and it's really not that hard. Before you rewrite it, you got to get that by itself. So we got to do two things. You got to get rid of that and that. So remember, you do the adding or subtracting first, so I'd have to subtract 7, and I would get 8. Then I would have to divide by 2, and I'd get 4. Okay, understand what I did? Since it's a plus 7, you'd have to get rid of it by subtracting 7. So then you still have this, but there's a number not inside it. So since it's times, you divide. Then once you have that, you can rewrite it. Put the same sign here, put the opposite sign there, and then get the x by itself. So remember, anything attached to the x goes last. You have to subtract 2, subtract 2, subtract 2. Then, don't forget that's a negative 2x. So when you divide by negative 2, ever remember what you got to do? Since it's inequalities, you got to switch the direction of the sign. So it'd be x is greater than, or not x, 3. Negative 6 over negative 2 is 3. Switch the sign. That's x. Switch the sign. 2 over negative 2 is negative 1. Okay.